Hilarious. All right, Jim, kick us off. I think we're ready.
Okay, great. So yeah, I want to welcome everyone to Cloud Native Scale here. We're a San Francisco-based meetup Cloud Native Foundation organization, and we're kind of all things GitOps around here. And today we're going to cover some very Kubernetes focused apps that are I feel are very critical and meaningful within the space. So just to do a brief summary, we'll be covering Flux. Flux's collection, of tools for keeping Kubernetes clusters in sync with configuration sources. Flagger, and Flagger does progressive delivery for Kubernetes operator and automates release processes, and Linkerd. And it's kind of a mesh service. It is a mesh service for Kubernetes that focuses, on being easy, quick, with a lot of security there. So it's very exciting, and I feel these are very, very meaningful and applicable tools here. And so today, our first speaker will be Kingdon Barrett. Kingdon's at Weaveworks. He's on the DX team there. Very much a longtime enthusiast of Helm and Ruby Go, and he does a lot of speaking. So he's doing a lot of GitOps conference and KubeCon for that, which is coming up there. And then second we'll have Jason Morgan from Buoyant, and he's a technical evangelist for Linkerity and co-chair of the of the excuse me, pardon me, the CNF committee.
Yeah, the CNCF Business Value Subcommittee. Sorry.
Great. Thank you for that. As I get tongue-tied and everything. Yeah. So Jason, also a very accomplished speaker, and is out there quite a bit, evangelizing these technologies, which are break down complex tech concept for that. So that's a bit. My name is Jim Walnum. I won't go into much of it. I've been in technology since the Jurassic, where large mainframes roamed the savannah. But I'm currently DevOps at a firm called CoinList, which is crypto oriented for that. So without much further ado, we'll start with Kingdon here.
Great. Awesome. Let me share my screen here.
You got it. You're good.
All right. Thanks everyone for coming today. I'm Kingdon. Thanks for the great introduction, Jim. I'm going to be working with Jason today to give a demo, but first we're going to do a little bit of introductory prep work for those of you who might not be familiar at all with Flux and Flagger. Since this is the Kubernetes oriented meetup, the Cloud Native meetup, I think we can probably assume some knowledge about Kubernetes, but I'm going to try to avoid assuming pretty much anything along the way. And as long as everyone can actually see my slides, we can get started.
Yeah, so, I think you're good.
Great. Super. I'm Kingdon. I'm an open source support engineer at Weaveworks, which means I spend a lot of time working with our end users. I'm a maintainer of Flux, and I'm also known as Yebian. I'm the cow on Twitter. So a little outline of what we're gonna go through in these slides, and what comes after. We're gonna do a little introduction to Flux, and as part of that, we're gonna address the question of what is the Git Ops Toolkit. You may or may not have heard of the Git Ops Toolkit in association with Flux. We're gonna do an introduction to Flagger, progressive delivery operator, as it's been mentioned already, and we're going to do a little project update. So we're going to talk about what's new in Flux and also what's new in Flagger. Then, or somewhere in between, I think the way we've arranged the slides, we're actually going to break out for demo parts a couple of times with Jason. talk about Linkerd, Flux, and Flagger, the power of 3. And there will be interactive live demo parts. So,
and we can ask questions throughout your presentation.
Yes,
Yeah.
please. If there are questions, I won't be paying attention to Q&A, but you're welcome to raise them, especially if they're especially relevant.
Got
we
it.
love questions.
Okay.
So like I mentioned, there are some core concepts that we have to kind of get out of the way, and one is GitOps. We're going to have to understand what is GitOps, first of all. Like I said, Kubernetes, there are a couple of more interesting parts of Kubernetes that we need to understand, namely custom resource definitions. So the most important concept, I think, from GitOps and Kubernetes, for anyone who's not really familiar with those terms, or if you are, is declarative configuration. So the concept of declarative configuration means that we don't do things imperatively. We don't stand up a new node and give it a name and keep it as a pet and hold them out forever. These are resources that are disposable. Kubernetes is built on this concept of declarative resources. Along with that, so declarative configuration enables us to do this sort of automated continuous delivery dance that is really the pudding, the prize at the end. Along with that, I apologize, the transitions are a little bit messed up here. So besides automated continuous delivery, one of the other important features that we're going to get out of this is self-healing infrastructure. And as we go on, we're going to see how declarative configuration facilitates that. But declarative configuration is a concept we're going to come back to. Another important concept, it's actually not so much a concept as a specific tool that Flux is built upon, known as Customize. It's a SIG CLI project, SIG CLI Customize. And there's a API inside of Flux called customization that's built on top of it. Rather than dive right into Customize and what is Customize and how does it work, I'm going to do a lot of glossing over in the first part of this presentation to try to make things simple enough to understand for someone who has never seen them before. So Customize, or the Customize controller, we also refer to it as the plain YAML controller sometimes for demonstration purposes, because we have YAML manifests, Kubernetes YAML, we want to apply it to the cluster, and it's a lot easier to explain to someone, just put your YAML in there and Customize, we'll put it on the cluster, than to actually go into detail about what Customize is and what it does and what it's for. Rather than all that, we're actually going to talk about how it works together with the rest of Flux. So Customize controller, or the plain YAML controller, does not function by itself. It works together with the other parts of the GitOps toolkit. So what is the GitOps toolkit? I'm going to explain by telling what it does, or more over how it's designed. And this is sort of the Unix philosophy of design of software. We've seen it before, where we want one small tool to do the small tool job and not become a large tool that does many different things. It should just do the one job. So the methodology of design underpinning the GitOps toolkit and Flux is this concept of separating tasks into different APIs. We separate them by responsibility, and two responsibilities up front, we've already touched on a little bit, is the Git repository and a customization. So to Flux, these are two separate jobs, and there's a historical reason why, but it's not really important. What's really important is that if there's a failure in either part, it's easy to diagnose, and also as in terms of maintenance and keeping these parts well built and well oiled. It's much easier to maintain a component that just synchronizes from a Git repository to local artifacts in a cache than previous design of Flux. So the other half is the customized controller that takes those artifacts from the cache and it applies them to the cluster through a filter. The filter is known as a customized overlay. Again, that's not super important right now, but that's part of customize. And it does this in a loop. So every time the customized controller hits this reconcile loop, it's going to look at the manifests in the cache from the Git repository, the most recent commit in the Git repository, and it's going to apply them to the cluster. Now that would be pretty cool if that was all that Flux did, but Git Ops Toolkit is for many separate jobs. So what else does Flux do? Well, Flux can also manage Helm releases. So we're talking about plain YAML. Helm is probably familiar to a lot of people on the call right now already. We know what Helm is for. It's for vendors, really, in my opinion, at least. Software delivery from a vendor to a user. Right now in Kubernetes, there's nothing that beats Helm as far as configurability goes and usability. It gives you a lot of nice things out of the box, like it will potentially wait until all of the resources are online. Anyway, not to belabor about Helm controller, there are other jobs like the notification controller. So as these releases are unfolding on the cluster, we need a way of finding out how it's going. We can probe the cluster with kube control. We can do lots of things with health checks, but what really we would like, I think, in a lot of cases, is for notifications to go out if something is wrong, and that's what the notification controller is for. So a provider is something like Slack or MS Teams, can send your notifications to, and the notifications are just events that come in on Flux resources. So all of these different events, all of these different resources have events associated with them. So, okay, so we've got core controllers. This is really where we want to focus first to understand what's going on in Flux. We've got the customized controller and the source controller. The source controller is basically the brain of Flux. So that means that all of the really heavy lifting is done in the source controller. Integration with different Git providers. So we've got the Helm controller and the notification controller. And that's an awful lot for starters. For anyone who really hasn't seen this stuff before, I want to take a little pause here and think about what we learned so far. So we know we can apply YAML to the cluster now. That's the thing.
So we actually had a couple of questions that came up while you were talking. So yeah. I can't see their name. Dayanand was asking if Flux is a CI/CD tool.
That's a great question. Flux is, as a Flux CD org name implies, CD tool only. CI is a separate responsibility. So like we've been talking about dividing jobs into smaller tasks, Flux does this, and it focuses only on the CD end. So if you have a CI tool for building images and testing images, it will work great with Flux. That's part of the proposition. So we're having our little intermission here, and I need to plug for my overlords here. I need to plug our event that's coming up. This is our Flux ecosystem event, where you can go and see all of the different vendors that are building solutions on Flux right now. So Microsoft, Amazon, VMware, D2IQ, and of course Weaveworks all have solutions that are built on Flux. They'll be presented here at this GitOps one-stop shop event. This is coming up on October 20th, the week after KubeCon. And while I'm plugging things, these slides are developed in Rabbit, an open source slide development tool. We're missing something, aren't we?
No, I think the next part comes after the Git Ops Toolkit.
Okay, all right. So that was a nice intermission. Do we have any more questions while we're breaking?
We've got a couple in the Q&A, but I'm answering them directly in chat.
Okay,
and
super.
they've
We'll
both
keep-
been
we'll keep
Flagger
going.
related. Yeah, they've both
Yeah.
been Flagger related, so we'll dive a lot deeper into them when we get to the Flagger section.
Okay. So this is our little diagram of the most important part of Flux first. The source controller and the customized controller that work together to get YAMLs on your cluster. I'm not advancing the slide forward. Okay, here we go. So that's what I just said. The main job of Flux is to sync YAML manifests from a Git repository to a Kubernetes cluster. That's pretty much all I've said so far. But we've undersold the complexity a little bit because we might not just have one Git repository, and we might have different things that we want to be applied in different reconciliation cycles, things that are not related. We like them to be able to fail independently. Like, let's say you pass in a manifest that's not valid. Sorry, I've got a barking dog downstairs. It's distracting. So Flux scales those operations by creating CRDs. As you need a new Git repository, you create a new YAML manifest for that Git repository, and then Flux will synchronize more Git repositories. Or if you need a different branch ref, these are all ways that you can scale Flux to using more users and deploying more applications. So source controller is the brain of Flux. We kind of said that. But from a user perspective, customized controller is really more important to know the details about. There's a lot more to learn in there. There's a lot more to get your hands dirty with. Git repository, you sync it to the cluster and you're pretty much done. As far as things to focus on, if you're learning Flux, there are a few links on the coming slides that you might want to check out. Yeah, this is the business end of Flux. So it's big, it's a lot to learn. And in fact, there's at least 2 major tutorials that you can follow. There's a multi-tenancy tutorial and the customized Helm example tutorial on the Flux GitHub website. These are referred to from the docs. And these are tutorials that show all the building blocks. So the way the documentation is organized right now, unfortunately, it's not always easy to go in and find the thing that you need. The way it's organized more is to try to get you exposed to all of the features of Flux at once, as much as possible, in furtherance of a larger goal. Like, we need multiple environments on our cluster, or we need to satisfy multiple tenants and keep them isolated from each other. So those are 2 tutorials that you should check out. And if those seem a little big and we like this view of Flux where just 2 pieces and they talk to each other, there's a getting started guide. That's the place to start. We're going to take through a little bit more whirlwind as we go on. But like I said, I oversimplified a little bit. The source controller doesn't just manage one CRD. There are different sources, right? The Helm controller and the source controller work together to manage Helm artifacts. You can also use an S3 bucket in case a Git repository doesn't fit for you for one reason or another. One use case that makes this very attractive is you have a very large set of manifests and your Git repository is not in your VPC, and you'd like for there to be low latency between the source of the manifests and your cluster. So you want to host something inside your VPC, but you don't want to go full GitLab. You can store the manifests maybe as an intermediary in the bucket. This helps save on bandwidth, for example. So anyway, I said this would be a rapid introduction.
Just one question that popped up in the QA that I thought you might want to answer live. Is the Git Ops Toolkit the same as Flux v2?
Yes, I'm going to say yes, because it's easier to say yes. Semantically, we have a whole disambiguation page internally for us to try to help make sure we're using the right word when we talk about a thing. But the easiest way to explain it is to say that Flux v2 is the user-facing part, or the whole project, or the team. The Git Ops Toolkit is the API, or the part that the components are built on, or the design.
I think, Stacy, did you want to comment on that?
No, I was suggesting that Kingdon answer it live,
Oh,
so that's perfect.
I apologize. I apologize.
No
Let me just do a brief introduction for Stacy. Stacy is a community manager over at Weaveworks, and she's awesome. So she might chime in occasionally. So thanks.
So the reason that this link is here in this place is because we have fully documented, of course, all of these CRDs and all of the components of Flux, and you can read about them in a tree here. If you really don't want to gloss over, you want to know all the details. That's the easiest entry point there. Then you can go and read more about the details of any of the CRDs in Flux. But if you come away with only one thing from this part of the demo, remember the source controller and the customized controller, because they're going to come back later and we're going to have to use them. Before we get to the actual demo parts, there are more components of Flux than just those four. And there should be some build up here. I'm not very good at dramatic pauses, so the image update automation is the important feature of Flux that I don't want to gloss over. We don't always have room in demos to show this. I'm not sure we're going to have room to show it in a demo today either. But this is the killer feature that I think brought Flux to the limelight in the first place. We're not just taking manifests from a Git repository and syncing them to the cluster. This is a closed loop with automation that goes both ways. So the cluster knows what images there are, and because of the image reflector controller, the cluster can keep tabs on the state of those repositories and look for the latest image. And when the cluster sees through a policy that you define, so maybe you say, we like the latest semver release, this is the most common policy that you would use in Flux. When a new image is published with a semver release number higher than the release that you have deployed, Flux is going to, the image automation controller is going to commit that back to the repo so that the customized controller can deploy it. So when we get our updated image through the image reflector, image automation controller actually writes that back to the Git repo. This is where a lot of people get scared because, well, there's lots of good reasons to be scared here. We're giving write access to the cluster. This is what we're trying to avoid, right? We separated our CI system from our CD system. We've got complex logic, but it's you know, it's in a small box. There's not a lot that can go wrong here. Famous last words, of course, but here's the whole cast of characters. These are all of the controllers of Flux. And this is what we just had a brief introduction to, all of those things. So that's about all the time we have for just Flux.
There's, you actually have, looks like 3 good live Q&A questions. So
Cool.
Does Flux use OpenTelemetry?
I'm not aware of any integration between Flux and OpenTelemetry.
Awesome.
I think that might be more. No, I don't know anything about that. Sorry.
Is it possible to use the auto update for Helm charts as well? And this is from Adrian. Sorry, last person, I forgot to read your name.
Yes and no. Let's hear the third question.
Well, so it's define a policy for Helm app version upgrades that would be pushed to the repo. And then their third question was, is there a UI component for Flux planned in the future, similar to the Argo CD UI, or do we need to go to Weaveworks Cloud?
Okay, I'm going to go to the Helm chart automation question first, because that's, you can define the release version of the Helm chart that you want to install with a semver expression. So if you say, I would like to install the Jenkins chart that's version 4.x.x or higher, but not 5.x, because that's probably a breaking change since it's a major version increment, you can do that. And it's not exactly using the image automation controller. It's a different type of automation. But yes, we've tried to spread these automations around all of the different places. Another surprising maybe place that you can use this is in a Git repository definition. You can pick the latest semver tag from the Git repository and sync that release to the cluster in case you keep your manifests in a config repo that you version with tags. There are lots of different ways you can use that. And the Flux UI question, I don't really have a great answer for that. I'm sorry. We don't have a lot of resources devoted to mostly volunteer resources for the UI. So we don't really have a great plan for the UI moving forward, other than to say you should really check out GitOps because that's where the resources for the UI are devoted at this point. So we have more questions before.
We do, but Andreas, I think, is happy if we just answer in the chat after this.
Okay. Oops, what happened here? Yep. So I'm going to hand over to Jason. We've got a couple of slides about Linkerd.
Awesome. Thank you. Yeah, do you mind going to that? Perfect. So, hey, folks, thanks everyone for listening, and thanks a ton, King. That was super helpful on the GitOps side. So let's talk about service meshes really briefly. So I work for Buoyant, and it's my job to tell people to go try out and hopefully use Linkerd in production. So let's start off with what it is. It is a very lightweight, a very fast and security-focused service mesh dedicated to run in Kubernetes. It's been adopted by a lot of different folks. We've been in production for a while. We've got a Slack channel that I'd love you to join. We do weekly edge releases, and then we just recently graduated from the CNCF, so that means we met their top criteria for project maturity. Do you mind hopping over to the next slide? So what does Linkerd or really any service mesh do, right? Well, a service mesh works by inserting a bunch of essentially load balancers. We call them proxies. Inserting a bunch of proxies next to your applications, and then using those proxies to give you some benefit, right? And those benefits typically fall into three main buckets. Observability benefits, so make it easier to see what your applications are doing, how they're talking to each other, when things go wrong, where that problem might be, that sort of thing. Reliability features, so that you can again make your applications more highly available without having to write things into the application code around, retries or timeouts or whatever. And then the third big bucket that service mesh tend to get you benefits in is in security. So with something like Linkerd, you get MTLS between all your applications. MTLS it's not just encryption. It's not just an encrypted connection, but it's a mutually authenticated encrypted connection where each side knows who they're talking to, and they can be assured that, service A knows for sure it's talking to service B. And Linkerd gives you those benefits in a way that is focused on being really simple to use, right? So what we're going to do today is we're going to install Linkerd. We're going to install Flux, Flagger. We're going to do some progressive delivery, and it's all going to be fairly simple to configure. And we're going to integrate it with an ingress. So we're actually going to use the Ambassador edge stack to do our ingress. Sound good? Any questions before I move on?
Sounds awesome.
Sounds good.
Y'all want to do a quick demo?
Yay.
Yeah.
All right. Okay, so let me share my screen. Can everybody see a bunch of terminals?
Yes.
Nice. Good. Let me shrink this. Maybe I can't. There we go. All right. So let's get started. So here I'm running, so someone asked earlier about a K3S cluster, whether you can use this with K3S or Kubernetes. In this case, I'm actually running on a K3s cluster provided by the folks over at Civo. So here I've got a simple cluster up and running. It's got 3 nodes, and we're going to install a bunch of stuff on it. So let's kick off. So actually, before I do that, let me step back for a sec. When I think about GitOps, right? I think about, you know, like what's the point, right? And what do I get out of it, right? So my point is I want to make it easier to configure my clusters in a very standardized way, right? And when I first read about GitOps from that that Weave kind of manifesto post, I kind of got the idea that I could put a bunch of YAML into a Git repo, and I could apply that YAML as it is to my Kubernetes cluster, and eventually the Kubernetes reconciliation loops would kind of just get me to where I needed to be, right? But like that was ultimately kind of an immature understanding of how to do it, right? So what I need here in my environment, I'm going to use the service mesh to encrypt all the connections between my apps. And I'm going to use Flagger to do progressive delivery, which will rely on the service mesh. I'm going to install the Ambassador Edge stack, but I don't want to install it until I'm ready for Linkerd to add its traffic into that mesh. So I have an order of operation that matters and that has to be respected. So we're going to use Flux to install a platform and install some apps, but do everything in an order that allows everything to come up, right? The way it's supposed to, and never leave us vulnerable to, hey, the traffic between this app and its database might not be encrypted at any point. The thing that I'm not going to do, so typically, right, like what you'll see here is I'm going to do a CLI-driven install of Flux or bootstrapping of that cluster. And that's because I'm trying to show it as opposed to do it in a production scenario. But like in a real use case, I wouldn't expect you to be using the CLI to actually bootstrap your clusters. So with that big preamble, let's talk about this. So I'm running a K3s cluster. So let's check first if Flux is a viable thing to install. So we can use their pre-check command to just validate that this is a good target. We see that it is great. So we can go ahead and do the install. And I see Thomas, I see your question. I'll answer it once we get to a bit of a pause. Actually, I'll do it right now. How far can we push the observability from Linkerd Viz for all the server speaks first things? In one example, I'm curious about Redis. So that's a really great question. So the service mesh basically gives you, the proxies will understand the traffic between your applications in most cases. So if you're doing gRPC or an HTTP connection between apps, right, the proxy is able to understand how those systems talk to each other and give you details about their conversation that we use to get a lot of benefits for observability. And we'll see that in the demo when we look at the dashboard. For something like a connection between your app and Redis or your app and a MySQL database, right? Those protocols aren't understood by the proxy in the same way, right? So basically the way they're having that conversation, you know, the proxy doesn't really try and understand it. It just looks at it as essentially a big TCP connection or like a trunk from one app to another, right? And it can just give you some details about the connection without understanding what's being said. I hope that makes sense, Thomas. So you'll get TCP level metrics for a conversation between an app and Redis, and you won't get deeper metrics beyond that. Okay, so we've installed Flux. We're just going to validate that this is a valid target for Linkerd. So let's go ahead and do that. We see that it's pretty good, except for we've got some pod security policies that we're gonna want to get rid of because those are being deprecated. So now let's actually go get it going. So the first thing Kingdon talked about when we talked about Flux is there was source. There's essentially two things, right? There's like the store of information that we're going to use to do stuff, and then the stuff that we're going to do. So what we're doing is we're creating a store here, a Git repo for this demo. So let's look at this, right? So Git repositories are a custom resource definition. That's part of the Git Ops Toolkit. We're going to create one. We're going to call it Git Ops because I'm not crazy creative. and then we're going to link it to the main branch on this particular Git repo. And if anyone wants to follow along, feel free to grab the Git repo and run it yourself. It requires you to have a K3S tool called K3D, which lets you spin up in-memory Kubernetes clusters, but otherwise pretty easy to use. So we're going to take that repo custom resource definition. We're just going to apply it directly to our kube cluster. So now I can look down below and I can do kget git repository. And I can see that we've got, we were able to pull it, what revision of it we pulled and how long ago. So we're ready to start adding some stuff in. So the first thing we're going to do is lay down our platform, right? And our platform's got a lot of stuff and it can't apply in order. So I'm going to apply it now, and then we're going to talk about what's in this YAML manifest after. So I created, looks like 5 customizations. I'm actually using both the customize and the Helm controller, but we'll talk about that in just a sec. What I'm doing here is, in spite of the fact that I said install 5 things, I'm not gonna install all 5 of those things in parallel, right? I'm gonna do some of them in sequence and some of them in parallel. So I need the first thing I want installed in this environment is my base service mesh, because everything else is gonna rely on that to do encrypted communication, right? So we're installing Linkerity first. And once Linkerity is done, we're gonna install the Linkerity Dashboard. And then when the dashboard's done, which includes a built-in Prometheus instance, Ambassador and Flagger are gonna install in parallel. And then after everything's ready, I've got a final customization called Finalizers, which is just gonna give me some hosts and some mapping resources for Ambassador to allow me to get a properly encrypted entry point to my various applications. Hopefully that makes sense. I see Samir's asking if Linkerity can be deployed without Flux. Absolutely. So Linkerity can install via Helm, via CLI, and then of course with Flux. Or really whatever tooling you use. If you can apply YAML to your kube cluster, it can install Linkerity. So let's take a look at this manifest, right, and what we have in here. So we start off installing Linkerity. It doesn't have any dependencies, so we'll let it go first. We show where it is in the repo, what repo to go to, and then this is really clutch, right? So when I was first working with Flux, I didn't understand health checks, and it caused me some issues. But what I have here is I have a manifest that defines a bunch of deployments, and in my repo I say, hey, listen, track on these deployments for the Linkerd install, and don't accept that it's done until all those health checks say they're ready, until all these deployments say they're ready to go. Right. Then after that, we look at Linkerd viz, and we tell it don't install until Linkerd is there. Excuse me. Right, because we want Linkerd first before we try and install the dashboard, because it won't work without it. And again, I set up appropriate health checks so that all the deployments under Linkerd viz are tracked. So these are straight customizations, right? I'm just taking raw YAML in a repo and applying it. And with Ambassador, we're actually going to get tricky. And Kingdon actually offered me a bunch of help while I was doing this, which I'm super grateful for. Thank you. So here, I'm installing Ambassador. But in the case of Ambassador, I'm not creating, I didn't put all the Ambassador YAML directly in the Git repo. What I did is I created a Helm release manifest, right? And I'm applying that Helm release manifest. And I'm letting the Ambassador Helm release manage itself using that Flux Helm release controller. And so we see here on the right, we now have Ambassador edge stack up and running, where we had to delay it behind Linkerd and Linkerd viz, because I wanted the actual edge stack itself, the ingress, to be injected right in Linkerd. So we see that these edge stack components both have 2 containers per pod. That's the actual ingress itself, as well as a Linkerd proxy ingress, or a Linkerd proxy pod or container. Jeez, sorry folks.
So the reason you're doing this is because Ambassador delivers their Ambassador stack as a Helm chart, namely.
Yeah, that's the easiest way to install it. You know, beyond that, we're going to do Flagger. So both Flagger and Ambassador are going to run in parallel. Well, they've already run at this point, but they're going to run in parallel so that we can, because neither of them depend on each other. They can just both install when they're ready. And then my last thing is this set of finalizers. And the finalizers include just a bunch of host entries that will allow us to look at what's going on. And let me actually just check on the state of my hosts right now. Yeah, perfect. So if y'all want to go to dashboard.civo.59s.io, and I'll put that in the chat when I can find it. There we go. You can see the Linkerity dashboard for this environment. And I'll actually bring it up on screen because why would I not? So here, we've exposed the Linkerity dashboard for this cluster to the internet. It's going from, and actually we're going to be able to see it, but we're going from the Ambassador ingress through to the Linkerity dashboard. Oh, anonymous attendee. That's a great question that I'll answer in a little bit. So I can see the Ambassador edge stack itself. If I go click on it, I can see who all it's talking to. So right now, right, we see that it's talking to Prometheus, a bunch of unmeshed endpoints are coming in talking to the Ambassador edge stack, and the Ambassador edge stack is sending requests over to this dashboard service. So that's all, like all these requests per second that you're seeing here, that's actually traffic from you in the audience. So thank you very much for that. And I'm going to have a bunch more links for you in a minute, but that's where we start. So feel free, putz around, check out that. It's about to get more exciting because now that we've done our platform, we can do our applications. So let's not talk about it and instead be about it. So we're going to deploy some apps. 3 apps in total. One called Books app, which is a broken application that you can look into Linkerity, look into that dashboard, see if you can figure out how it's broken, right? Emoji Voto, same thing, also broken, and pod info. And if you look now, if you go to Emoji Voto or Books app or pretty soon pod info, you'll see a site there that you can browse to. So let me just put these in the chat. So there's Emoji Voto, there's Books app. Nice thing, I'm using Ambassador to handle all the certificate getting for me, and hopefully Emoji Voto comes up in a minute. All right, so let's look at that manifest before we do anything else. So we have a customization, right? I set these app deployments to depend on my finalizers. So the nice thing is if I put all these in a single manifest, right? But at no point do I want pod info to be sending traffic that's not encrypted. Maybe I have a PCI requirement where all app traffic has to be encrypted, right? I can use Flux to say, hey, wait until everything's ready, then go ahead and allow my individual apps to deploy. Ambassador is an entirely different tool. It is, sorry, Dayanand. Ambassador is an entirely different tool that is just an ingress. So you can use any old ingress with Linkerity. It only handles the app-to-app traffic inside your Kubernetes cluster. I use Ambassador a lot because I've gotten used to it and I really like it. All right. So let me finish going through this and then I'll answer more questions and we'll go back to the slides for a minute. So pod info, I talk about what it is as well as giving it the various deployments inside pod info. Emoji Voto, same thing, right? I just say, what does it depend on and what things should we track to make sure it's healthy, as well as for Books app. And that's kind of the extent. With everything, we can just do like a Linkerity check to make sure that our environment's happy and healthy. It's able to see that everything's good, and it's kind of all for this portion of the demo. We're going to go back to slides, and then we're going to go back and do a Flagger demo. But feel free to explore those apps while you're at it. Is it okay? Do I have time to answer these questions?
Yeah.
Okay, so for Thomas, how far can we push? Oh, I already answered that. Got it. Sorry. Anonymous, how is Linkerity different from Istio? Right. Well, to be clear, right, like it's my job to promote Linkerity. So take what I say with a grain of salt. But Linkerity is focused entirely on Kubernetes. So we don't worry about cases outside of your kube cluster. We don't do like Linkerity doesn't go into being an API gateway. Linkerity doesn't go into ingress. It only concerns itself with east-west traffic inside your cluster. It's generally a lot simpler and more straightforward to manage, right? Like there are currently 2 custom resource definitions within Linkerd, neither of which are required to actually use it, right? One of them is the SMI traffic split. The other is a service profile that you can use to build in retries or other reliability logic. Those are the big ones. Linkerd doesn't use Envoy, right? Linkerd uses a custom-built proxy called the Linkerd 2 proxy. Yeah, those would be the big differences from my perspective. Try it out, see if you like it. If you're looking for, Linkerd a lot. There's actually going to be a talk at Service Mesh Con from some folks who tested Linkerd at, I think it was 2.5 million requests per second, and they found that was it was the most performant out of the various meshes that they tried out. Okay, so those are all the Linkerd questions. So I can leave that for now.
So I can field these other 2 questions we have open here.
Okay.
How does Flux handle private repos, and does it use a personal access token? Flux uses a private repo by default. If you follow the Bootstrap guide, you will get a private repo, and it uses the personal access token to create a deploy key. So you can handle deploy keys manually if you don't like the way that personal access tokens work, or you can use a personal access token to connect deploy keys, and it's very easy through Bootstrap. There's another question that's a little bit technical about Helm releases. This is a tough one. I have an answer. It's not a great answer. So the question is, I deploy a Helm release and it has a Flagger Canary, and after the first deployment, the connection between the 2 is lost. So the Helm release can be successful, but the Flagger Canary fails, but the Helm release does not know about it. This is sort of a defect in the way that Helm handles things that are scaled to 0. I can follow this up with you later because the answer might not be relevant to a lot of people on the stream. But the answer right now is add more health checks to your customization. That's the TLDR answer. If you health check the resources that you expect to become ready, then the customization will wait for them to become ready before it reports that it's ready. And the Helm release, there's nothing you can do about. We have to honor the behavior of Helm upstream. So share my screen again here. We've got a couple more slides. So we saw a little bit of Linkerd. We saw a little bit of Flux. We saw Flux deploying Flagger, but we didn't really talk much about Flagger. And I guess we put the cart before the horse a little bit with that question, because we haven't really talked about canaries and what they're for and how they work. So Flagger is for progressive delivery, of course. Flagger leans heavily on Linkerd and tools like it to provide this service known as a canary release. And there are different types of canaries. The basic one we're going to talk about is just canary, which is a new version that's deployed, but we're not sure. Basically, that's the easiest way to explain how Canary works. Is we'd like to put this new version out. We haven't tested it extensively, or maybe we've tested it, but not to the extent that we can do in production. And we'd like to see maybe 5% of our users on this new app and running successfully and happy by whatever metrics we collect with Prometheus and Linkerd before we start shifting more traffic. And then as our confidence in the release grows, we shift more and more traffic to the release until finally we're 50% or more, or maybe 100% on the new release, and we can just cut over. So GitOps and Flagger not necessarily have to be used together, just like Linkerd and Flux don't have to be used together, but they work really well together. So this is kind of a picture of how this works. With your optional Helm component, you have a Canary resource and let's say a Helm release. This doesn't have to be a Helm release. It can be a customized regular deployment from plain YAML. And Flux communicates with Flagger by pushing a new release to the cluster, which Flagger then observes through Prometheus based on the metrics that you configure in the Canary in order to determine how the release is going. So that all sounds very complicated, and it's worth it maybe at this point to step back and say, why are we doing all of this? It seems very complicated. There's very good reason, because we want to do safer releases. And we want to make our releases safe so we can explain to people how we can do 1,000 releases a day and not really be afraid of that. If we have large distributed teams, how do we know, when releases are maybe 1,000 a day is over, overselling a little bit, but for some teams, that's how many they do. So we want to be able to route traffic flexibly. And in order to do that, we need something like a service mesh. So Linkerd, Istio, Open Service Mesh, or AWS App Mesh are all examples of service meshes that you can use to do this flexible traffic routing. And if you're not at a stage where you are really ready to adopt a service mesh yet, it's okay. If you're using an ingress controller from this list, you can also use it with Flagger. So really what we're doing with Flagger is we're validating our releases. Every time we're pushing a change to the cluster under this Canary, we want to know that all of our metrics that we collect are still okay. And if they're not okay, so we have acceptance or load tests that might be part of our Canary rollout. If things are not okay, according to those acceptance or load tests or custom metrics that we can define in YAML. I made it this far through the presentation without showing any YAML. I apologize. I had to show some. It's a Kubernetes presentation. More detail about how this Canary actually works. The target ref, this is the resource that is duplicated for the Canary. So there's a primary and a Canary resource. It'll become a little clearer when we see it on the Linkerity dashboard in the next part of the demo, exactly what's happening. But this is a good boiled down explanation. So these are the resources that we actually described in our YAML files: a deployment, a horizontal pod autoscaler, an ingress, and a Canary. This might not be an actual ingress, depending on what you're using for ingress controller, like Jason's using Ambassador. So for Jason, it's a mapping instead of an ingress. Flagger generates all of these other resources. We actually skipped service up here on purpose because Flagger is going to create this called an Apex service that decides whether it should route traffic to the Canary or the primary at any given time based on the information that's in a traffic split. And this is not a Linkerd traffic split. This is an SMI traffic split, but this varies depending on how you use Flagger, whether it's with Linkerd or another tool. So as far as promotion, what happens at the end of a successful rollout is automated Canary promotion. That's when the Canary resource that we've now tested and verified is copied to the primary that's been serving most of the traffic for most of the Canary rollout time. And this is the control loop that Flagger implements. This is what Flagger does. So based on the analysis, of the metrics or your key performance indicators, whatever metrics you decide, could be latency or request success, the canary is either promoted or it's aborted, and it returns to the previous state. So this is automated Canary Promotion supported by all declarative configuration. We're gradually shifting traffic to the Canary while we're measuring the key performance indicators. And the result is where we started. We want self-healing infrastructure. If something goes wrong, we want the cluster to know that it should return to the previous state and send up some warning bells so someone can come and take a look. So I think actually we're going to break for more demo before we go into news. There's a couple of Flux and Flagger news slides, but I'd like to see the Canary. You ready for the rest of the demo, Jason?
Yeah, awesome.
All right.
So folks, if you did get that dashboard link earlier, you can also follow along with Linkerity Dashboard. So I'll show you where to go before I do too much here. So let's look at this. So let's watch two sites, okay? So we're going to go, want to use pod info? Yeah, perfect. Here's pod info. So we're going to do a blue-green, or in our case, green-blue deploy. I'm pretty literal, so you're ideally going to see what's happening fairly easily. When you go into the Linkerity Dashboard, go check out namespaces and pop over into pod info. So one thing, just a quick tip using Linkerity, take your namespaces. You can sort by success rate, so you can quickly find what namespaces you're having problems in. And I won't bother to diagnose it, but bonus points to anyone that knows what's wrong with Emoji Voto and Books app by the end of this. We can go peek at pod info. We can see what this app looks like, right? So shockingly, I've got a traffic generator, a little front end, and a back end, which is my pod info primary. Here you can see a ton of traffic is hitting the front end and is being passed over to this pod info primary deployment. But when the Canary starts, we're going to see that traffic split between multiple deployments, right? Specifically pod info and pod info primary. Down here we have a traffic split, right? So this is where you can actually see how much traffic is going to what version of the service. So this is where you'll want to look if you're just looking on your own. So with that, let's go actually do a Canary. So we're going to do micro apps source pod info, and then I think it's the patch, right? So we're going to just edit our patch, and we're going to go from green to blue. 1919 ff git add dot git commit. Blue is better. We're gonna commit right to main because I like to live dangerously. Git push. And I should have cached my credentials before this. Sorry about that, folks. All right, so we pushed it. So we can do watch k or kubectl get customizations. Oh, oops. So we'll see once this starts off. Okay, so it hasn't done pod info yet. So we'll give it a minute to explore. What we're looking at on the right, so we're just looking at the pods in the pod info namespace. Let me make this a bit bigger. Come on, buddy. So we haven't seen any action kickoff. That's great. Our traffic split's still stable. Let's just browse around those objects that Kingdon was talking about. So if I do kget deploy, right? I only had the one deployment, right? In my manifest, but now I have two. Or I only had 3 deployments, but now I have 4 total, 2 pod info deployments. Pod info, which I defined, which has been scaled down to 0, and pod info primary. I wish I'd turned off my notifications here. Pod info primary, which actually has 2 pods in it, all of them injected with the Linkerity proxy, right, which is how we're getting information about the traffic. We also have a bunch of services, so kget service. We have the front end. We have the pod info service, which is kind of unique. So this is an Apex service. So this is a service mesh concept, right? So you're not going to find it. You're not going to, or it's an SMI concept, right? So that SMI is the service mesh interface. It's this attempt to take, some key functionality for all service meshes and put them in a generic object type. But anyway, this Apex service will allow you to say, okay, some percentage of traffic goes to one service, some percentage goes to another. And that's what our traffic split is actually doing. Our traffic split is manipulating that Apex service, or I guess, anyway, it's using that Apex service to decide where the traffic goes. Cool. And I guess with that, we might as well just kick it off and make it reconcile. So let's do Flux reconcile customization pod info. All right, I can't tab complete that. We're just going to force it to go. And what we're going to see when we do that reconciliation, we're going to see a bunch of stuff change. So we're going to get a new set of pods are going to get spun up. Right now, these are pod info pods, and they're going to get spun up with a different environment variable that changes that background color eventually. Yeah, perfect. So we can look at the canary state, see that it's progressing. We see we've got our new pods starting to spin up. Right now, the traffic is all going into pod info primary. But once these are ready, we're going to start to see some of it shift over. And you can look here in my terminal, or you can go look up here in the UI, and you'll see what's going on. So now pod info, where before it had 0, now it's got 2. Right now we don't have any success rates, and we don't have it on the graph because it hasn't started seeing traffic. But wait, traffic started coming in, right? And we can go down to our traffic split, and we can see, what percentage is going where, and what are the HTTP status codes? Are we seeing these being successful? Are we seeing them being performant? So Flagger has like a really nice integration directly with the Prometheus that Linkerd brings along, and it's using the metrics from the service mesh, metrics that you got for free by adding Linkerd to the app, to determine if this is still healthy, if it's performant. So what's the success rate? What's the latency, right, by latency bucket? And does it meet our criteria for testing it? And if you go over to pod info, right, and check out this page, you're going to see it do its blue-green deployment as we're watching. Yeah, that's kind of the big neat thing. You can use, if you want to do canaries at the ingress, you can do canaries at the ingress. If you want to do canaries at the service mesh level, you can do them at the service mesh level. You got lots of options in this case. So yeah, Kingdon, anything you want to add here?
So in your traditional blue-green deployment, I'm pretty sure you go from blue to green, Jason.
Right. Yeah, I did it backwards. I just didn't refresh my repo from last time. So yeah, and what we're gonna see here is when that canary is doing a ton of like automation for us, right, inside of our environment, right? So it's telling a deployment to scale up. And then once it's happy with the test that it's running, it's going to go ahead and scale it back down to 0, right? So we can see down here in our terminal, right, we're at whatever, 55% here. We can actually look at the canary object because that's actually kind of nice. Kget canary -o YAML. We can see like what we actually defined here. I know there's a lot going on, but we'll get to the part that's interesting. So, right, we set the interval at 5 seconds. We say go up to 95%. These are the things that we care about. Thank you, Sebastian. That's very helpful. Red and black is definitely solid. Nicholas asks a great question. Do I have to use the Prometheus that comes with Linkerd? You absolutely do not. No requirement at all. You don't even need Linkerd Viz. Right, so you can collect like Linkerity, all these metrics that Linkerity is using are being scraped or can be scraped by any Prometheus instance, right? And there's a standard Prometheus config that you can use to bring your own Prometheus instance with Linkerity. And then you just, when you install Flagger, instead of pointing it at the URL for the Linkerity Prometheus, you'd point it at your URL. And if you have questions, please join us over on slack.linkerdy.io, and you can get, I'm happy to answer them directly, and you can also see in our docs about bringing your own Prometheus. Great questions, folks. Yeah, okay, so now we see the now that we've hit our 95%, right, and everything was happy, what Flagger's doing is it's creating 2 new podinfo primary instances, and once they become healthy, it's turning off the old ones. So pretty soon you're only going to be able to see blue traffic in podinfo, right? And then this podinfo primary deployment, or this podinfo deployment, is going to scale back down to 0. We're not going to see any traffic here. And if we want to look, we can actually go dive in, see like the live calls that are actually calling. So what endpoints are being hit on this app. If anyone wants to go to podinfo and hit like the status 502 app, we'll start to see some errors come in here. But yeah, so we can see what like actual URLs are being explored, and how they're performing. And we can tap live traffic, do some things like that. I think that's kind of all of the demo. If there's anything anyone wants me to explore, let me know, because I'm in the system and happy to poke around. And then for folks that are out there, please feel free to use that dashboard link as long as you like.
That is great. Man, I'm even thinking for me, personally in my current role, we have some of these issues that are we're kind of looking for things. So this is a fantastic demo and presentation.
Awesome. Well, total pleasure to do it.
Great. Are there any more questions before we kind of wrap this up here? I think we've answered quite a few, and
We have a couple more slides for project updates.
oh yes,
Yeah,
that's perfect. Sorry, Kingdon, please
it's okay.
continue.
Go rapid fire through these. Okay. So, all right, we did all these things. And now we're going to do our project updates. Yeah, okay, so the latest release of Flux at this point is 0.17.2, which has a minor upgrade of Customize to 4.3 and some other nice features, including bug fixes. The most important milestone that's happened recently in Flux development is this 0.16.0 release, where we declared all of our APIs were promoted to beta status. That is, in our terms, considered stable. And for systems integrators, it's our signal to systems integrators that they can build on top of Flux, and they don't need to worry about us going in and breaking their things. There were some breaking changes in 0.15. This was unavoidable if you haven't upgraded since before June. If you're a Flux user already, you need to be aware of those. Always check the release notes. And coming soon, we have this customized controller PR that's open to bring server-side reconciliation, which is going to solve a lot of the problems that we talked about in terms of health checks. You will not have to write as many health checks anymore in future versions of Flux. Also, want to make sure everyone knows about my KubeCon talk. I'll be presenting GitOps and Jenkins with declarative everything on Wednesday. Hopefully, virtual visitors can see live as well. I'm really not sure how this is going to work, but I'm looking forward to it. And we have our GitOps one-stop shop event I already mentioned. Remember, if you are interested in participating in this, go to gitopsdays.com for demos from all of these companies, including Weaveworks. In Flagger news, we are continually adding metrics providers. That was the focus of the latest release in September. Dynatrace, InfluxDB, stack driver. And the release before that, we added support for open service mesh. So if you'd like to try Linkerd, you should try Linkerd first, but also don't forget we added support for open service mesh. So there's also a tutorial you can follow for that. Thanks.
I have two questions if you still have time.
Yeah, real quick.
Yeah, so a very basic one. I think in terms of sensitive information, maybe registry secrets, when you pull the images, how do you handle those kind of sensitive information in Git itself? That is my first question.
There is a SOPs guide in the Flux documentation that you should take a look at that shows how you can encrypt secrets for a GPG key or age. There's a couple of different encryption providers supported. If you're working in the cloud, you might have access to a key management. A lot of those are supported by SOPs. That's the solution that Flux is thanks for the link in chat. So basically you write them encrypted into the Git repo and you let Flux apply them to the cluster. So Flux in the Flux system namespace might be keeping a GPG secret, or depending on whether you're using KMS or not, it might not.
I think the second question is when I push my code to master branch or main branch, I want two things to happen. One is obviously build a Docker image and then also deploy. But in terms of GitOps, when you push, it kind of kicks off the deployment as well. And then there's a dependency on the build process. So how do you handle those scenarios on kind of segregating these two and then only work in sequence?
Yeah, this is a really common question. And I think that the reason it's so common is because people want to have fewer Git repos. And so they reject the idea of a config repo usually. I don't know if we highlight this very well in the Flux docs, but where your manifests come out of, it should be a config repo, not necessarily your application repo. If you have one application to deploy, that's the use case of Weave GitOps. That's what we built Weave GitOps for. So if you really want to use one repo, I would check out Weave GitOps. But also, if you're using Flux, it's a good idea to separate your manifests into a config repo. And then you can have push to your app that builds an image, and Flux image automation picks up the image and commits it for you to the config repo.
Okay.
All right, guys, we got to wrap it up. Do you want to wrap it up, Jim, real quick?
Yeah, first of all, I'd like to thank the presenters and everyone. Just like I mentioned before, just really great, very, very applicable real world applications. And I'd like to thank Stacy as well for being here on that. And and also say thanks to everyone who joined today. We had a really great crowd, which is very exciting for here. And then coming up next week on the 5th, here we have Martin and Scott doing some showcases and demos. I don't have any details on that right now, but be sure to sign up for that, October 5th, 10 a.m. Pacific time. And that's about it for anything. Any follow-ups? Any further comments here from anyone?
I would like to thank everybody. Thank you, Jason, Kingdon. Really, really appreciate it. I'd like to thank Stacy for helping in the background for working with us to get this event. We really, really appreciate it. And of course, you, Jim, appreciate your support, and we're looking forward to our event next week. Martin, just for those who don't know, is a Helm maintainer. So he's deeply knowledgeable about Helm. And then Scott is also a Helm and Flux maintainer. So we have two very, very good speakers next week, and look forward to seeing everybody. And that's it. The recording will be available tomorrow. So somebody was asking about that. And if you have any questions, reach out to us. I think you know how to do that. And everybody have a great day. Thanks so much.
Thanks, everyone.
Thank you.
All right. Bye.